Welcome everybody to Algebra 1, Section 8.4, Factoring Polynomials, and specifically trinomials when a equals 1. So, when a equals 1, it is going to be the same exact process as when a didn't equal 1. We're going to skip all of, if it lets me change my pen color, we'll see this up here, if it lets me write. And this, and go down to set 1. We're actually just going to start on the problem. Actually, scratch it. We're going to work on this guided example rather, but we're going to ignore what it says here. So with this guided example, we're going to do it the same exact way we did in section 3, where we make the x. On the top of the x, you do a times c, so we'd have 1 times 12, which is 12. On the bottom, we'd have the b, which is 7. And so we need two numbers that multiply to 12 and add up to 7. I want to pause the video to try to figure this out. It'd be two positives, and the factors of 12 that would add up to 7 would be 4 and 3, or 3 and 4. And so then we keep the first the same, so that'd be x squared, keep the last the same, plus 12. And you rewrite your middle by splitting it into plus 4x and plus 3x. And now we group the first two and the last two. The first two have a GCF of x, leaving you x plus 4. The last two have a GCF of positive 3, leaving you x plus 4. And so the x plus 4s are the same, so that's one of our factors or parentheses, and the other factor or parentheses x plus 3. And that'd be our answer. Now, you might be wondering, okay, well, if this is exactly the same as section 3, why is this in another section? Why wasn't this just included in the last section? Why are we doing this today? Great question. Well, the answer to that is because there's actually a shortcut here today. What is the shortcut, you may be wondering? Well, the shortcut is that when a equals 1, it's a 1x squared, or a 1 whatever variable squared, then you can take the sides of your tool, your x that we made, and put those into our factors. So the positive 4 and the positive 3 go along with our variable and give us x plus 4 and x plus 3. And that's our answer. We can skip the entire part where we split the middle term and we did all the grouping and we looked for those GCFs and go straight to your answers. And that's why section 4 is a thing. Because when a equals 1, there's a shortcut. Now, you can still do it the same way we did in section 3 on all of these problems today. Or you can do the shortcut, which is what I will be doing on all of these problems today. So, factor these polynomials. They're broken up into 4 sets, and it's just based upon where what numbers are positive and negative, which will affect what numbers in the parentheses are positive and negative. So, number 1 here, as we go ahead and make our x here for our trinomial, it would be a times c, or 20 at the top. The b is 9. And so we find two numbers that would multiply to the top and add to the bottom. It'd be two positives multiplying to a positive and adding to a positive. In order to multiply to a positive, you have to have either two positives or two negatives. And two negatives couldn't add up to positive 9. That'd be impossible. But two positives sure could. So, what would do the trick? Well, it'd be 5 and 4, or 4 and 5. And so now, using our shortcut, we're going to go ahead and make our two factors. And both are going to start with our variable n, with just a power of 1, where you don't really see an exponent. And then we're going to do the sides of our tool, or x. So plus 5 and plus 4. Which one goes in which parenthesis or factor doesn't matter a little bit. Or even a little bit, I should say. It doesn't matter at all. Because it's what's on the inside that counts. So, on to number 2. Do the same thing. We'll make the x. 18 at the top, because 1 times 18. 9 at the bottom is our b. The two numbers that would work. Let's figure this out. Let's try and figure it out on your own first. So I'd go ahead and encourage you to pause the video and continue on when you're done or stuck. It'd be two positive numbers. And it would be 6 and 3 that would do the trick. So we get w plus 6 and w plus 3 as our two factors. And then we'd be done. I'd encourage you to go ahead and continue on and do as many of these problems as you feel like you can get on your own successfully. And then to play the video again to check your work. Number 3 here. 1 times 24 is 24 on the top and 10 on the bottom. Two numbers that would do the trick, well, that would be 6 and 4, both positive. So it'd be a plus 6 and a plus 4. Number 4. 1 times 1 on the top and 2 on the bottom. Two numbers that multiply to 1 and add up to 2, well, that'd be positive 1 and positive 1. So it'd be y plus 1 and y plus 1. Now, there is an alternative way you could write your answer here. The alternative way you can write your answer here is you could write it as y plus 1 quantity squared. I don't care which of these two ways you write your answer. It's the exact same thing, no matter what. Because exponent of 2 just means there's 2 of whatever's being raised to the power. So there's just 2 y plus 1s, which is exactly what it says in pink. Now, you can always check your work on any of these problems by distributing back, and you will get exactly what we started with after you combine like terms as well. On to problem 5 here, you'll notice we'll start encountering some negatives since we moved to set 2. So 1 times negative 18 is negative 18 on the top and 3 on the bottom. So here, in order to multiply to a negative, we're going to have a negative and a positive. I still, out of habit, always put the negative on the left, even though we won't have to split and group on these problems. So the numbers that would do the trick here would be a negative 3 and a positive 6. And then for my shortcut, I would get n minus 3 and n plus 6. So I have to take the number and the sign with it in the parenthesis. Number 6 here, make my parenthesis, or make my x. 1 times negative 8 is negative 8. 2 on the bottom. Numbers that do the trick are going to be negative and a positive, and it's going to be negative 2, positive 4. X minus 2, x plus 4. Moving on to number 7 here, we make the x again. Negative 6 on the top and positive 1 on the bottom. Fill out the sides, and we'll have a negative 2 and a positive 3 doing the trick. We'll have g minus 2 as one factor, and g plus 3 is the other. Number 8, make the x, negative 45 on the top, positive 4 on the bottom. The sides end up being negative 5 and positive 9, which give me c minus 5 and c plus 9. Moving on to the next page, move into a new set of problems where both the b and c term are negative. So as I make the x here, I have negative 3 on top and negative 2 on the bottom. So my side numbers are still going to be one negative, one positive. This time it'll be negative 3 and positive 1, so the bigger number is negative, so that way they add up to a negative number. So my factors are going to be a minus 3 and a plus 1. Same process on 10, where I have negative 30 on top, negative 7 on bottom, negative 10 on the left, positive 3 on the right. So I have x minus 10, x plus 3. Number 11, on the side, I'll make my x, negative 63 at the top, negative 2 at the bottom. Sides of the x will be a negative 9 and a positive 7. So that's b minus 9 and b plus 7. Remember, if you're having a hard time finding these factors, you probably won't be quite as fast as I have because you haven't done it for multiple decades. But tricks for this, or tips for this, would be writing out those factors. So factors of 63 would be like 1 in 63, for example. 2 doesn't go into it, but 3 does 21 times. 4 doesn't, 5 doesn't, 6 does not, 7 does 9 times, and then we have actually exhausted or used all of them. And so finding them that way can be really helpful because then, oh, we have our entire list here. So here on number 12, we'll do negative 64 at the top, negative 12 at the bottom, negative and a positive again, and we're going to get negative 16, positive 4. And we're going to have k minus 16 and k plus 4. On a set 4, we have negative in the middle, but the right side, the c is positive. So on the top, we're going to have a positive 24. On the bottom, we're going to have a negative 11. And so this means the sides of my x or 2 here both have to be the same sign. And if they had two positives to multiply to a positive 24, that would work. But they wouldn't add up to a negative 11 or negative anything for that matter. So that means the sides have to be both negative in order to multiply to a positive at the top and add to a negative. And so 8 and 3, or 3 and 8, would do the trick. Once again, the order of those doesn't matter. So it's going to be x minus 8 and x minus 3, which once again, the order not mattering. Then we're going to do number 14 now. 49 on top, negative 14 on the bottom, negative 7 on the right and on the left. So we're going to have x minus 7 in one, x minus 7 in the other. And just like we had earlier, we could write this as x minus 7 quantity squared if you prefer. And once again, I really don't care which of the two you write it as. So just pick whichever one floats your boat. Number 15, so we make the x, we get 72 on the left, on the top, you see me, and negative 17 on the bottom. And two negatives here that would do the trick would be a 9 and an 8. So we have y minus 9 and y minus 8. And then number 16 here, we're going to have 50 at the top, negative 15 on the bottom, and it'd be negative 10 and negative 5. So we're going to have m minus 10 as one factor, and m minus 5 is the other. Moving on to number 17, we get into what's called mixed practice. This is just where it could be from set 1, 2, 3, or 4, aka the signs can be whatever. So on 17, as we make the x, we're going to have negative 17 on the top, or negative 16 on the top, positive 6 on the bottom. So I have a negative on top, meaning my signs are going to be different, one negative, one positive. And so it's going to be a negative 2 and a positive 8 that do the trick here as they really subtract since they're different signs and get 6. We're going to do a minus 2 and a plus 8. Number 18, negative 72 on the top, negative 14 on the bottom. These are again going to be different signs, so negative and a positive, and we've got to figure out what would do the trick. It'd be negative 18 and positive 4. So it's going to be x minus 18 and x plus 4. Number 19, 40 on the top, 30 on the bottom. And these are going to be two positives since they multiply to a positive and add to a positive both. And so it'd be 8 and 5, y plus 8 and y plus 5. Number 20, 48 at the top, negative 16 at the bottom. So we're going to have two negatives that do the trick because it multiplies to a positive, so they have to be the same sign, and add to a negative, so it have to be two negatives that do the trick. And this would be 12 and 4. So w minus 12 and w minus 4. On the number 21, negative 30 at the top and negative 1 at the bottom. Since it's a negative at the top, they're going to be one negative, one positive, and it'd be negative 6, positive 5 that do the trick. So we have n minus 6 for one factor, and n plus 5 for the other. chooses to, let me actually write it. We'll see though about that. Oh, it actually deleted something I had. That's a nice little twist. There we go. Number 22 here. 42 at the top and 13 at the bottom. And it'd be both positive, and it'd be a 7 and a 6 or a 6 and a 7. So it'd be k plus 7 and k plus 6. And then these next 6 problems are all going to have a GCF. And so we're going to do the GCF first, because as we look at these, we're like, oh no, we can't do the shortcut because A is not 1 on any of these problems. And we're like, oh, yet. Because number 23, GCF is 4, giving us k squared plus 3k plus 2. And now as we make the x, we're like, oh, okay, bet. This is going to be a 2 on the top, a 3 on the bottom now with our new a, b, and c. And so it's going to be a 2 and a 1, both positive, or a 1 and a 2. We don't really care the order there. And so one parenthesis here factor will be k plus 2. And the other parenthesis here factor will be k plus 1. And then you just have that 4 out in front and just drag it along like we did in section 3. So on number 24, we'll do the exact same thing, just a different GCF. This time the GCF is 2. And we're left with x squared minus 4x minus 12. And then we'll go ahead and make our x based upon these new numbers. And that'll give us negative 12 at the top and negative 4 at the bottom. And it'll be a negative and a positive, and it's negative 6 and positive 2. And so our factors are x minus 6 and x plus 2, with the GCF of 2 out in front. And that's our answer. Number 25, figure out what the GCF here is. Once again, I encourage you to pause the video at any point to work ahead and then play the video to check your answers or help if you're stuck. GCF here is 3, giving you y squared minus 5y plus 4. And then we make the x, and it's going to be 4 and negative 5 for the top and bottom respectively. And that'd be negative 4 and negative 1. That would multiply to positive 4 and add up to negative 5. And so one factor is y minus 4, and one factor is y minus 1 with the GCF of 3 out in front. Number 26 here, the GCF will be 3a. There's also a variable there. How neat. Giving us a squared plus 10a plus 21. Now as we make the x here, we're going to have 21 at the top. Then we're going to have 10 at the bottom. And so it'll be positive, and it'll be 3 and 7, 7 and 3. And so it'll be a plus 3, a plus 7, and the 3a out in front. So our GCF involved another variable. Number 27, the GCF is back to just being a number. Here it's 2. And we get b squared plus 10b, plus 5b plus 6. Make the x, 6 at the top, 5 at the bottom. Two numbers that do the trick are going to be positive 2 and positive 3. That multiply to 6 and add to 5. So our factors are going to be b plus 2 and b plus 3, with the 2 out in front as a GCF. Last but not least here, number 28. The GCF here is 5y. They all have a 5y in common. The last term doesn't have an x. So they don't have an x in common. And we get x squared minus 3x minus 28. And so our x, or our tool, becomes negative 20 at the top and negative 3 at the bottom. And so it'll be a negative and a positive that do the trick, and it'll be negative 7 and positive 4. And so we have x minus 7 for one factor and x plus 4 for the other, with 5y out in front. And that'll conclude lesson 4 for unit 8 for Algebra 1.